Hey, so after some suggestions of an additional video going over some problems, I figured it'd be good to just create a video where I go over the practice quiz, each of the questions on there, so you get to see my approach to doing this, and just get an additional kind of explanation to reinforce hopefully the ways that you guys are thinking about these problems and solving them yourself. So this should be a pretty short video where I go over each of the questions from the practice quiz. I've just put them into a PowerPoint, and then I'll answer them all on the slides. Okay. So the first question is to come up with the domains and ranges of each of these functions: cos inverse, sine inverse, and tan inverse. For cosine inverse, it's important to remember that the inputs are x's, x coordinates. So the things that you plug into cosine inverse are x coordinates from the unit circle, and it's going to give you an angle out. And so if you think about x coordinates on the unit circle, the x's range from -1, this is -1, 0, all the way to 1, 0. So the inputs to cos inverse are going to be numbers in that set from -1 to 1. And now the trickier one is, what range do you get from cos inverse? Since it's a function, it gives you one answer, one angle, and one angle only. For cosine inverse, it's only going to give you angles that are in the upper half plane, which is from 0 radians to pi radians. So it's going to give you some angle up here, one of these guys, any of these angles. And so the range for cosine inverse is from 0 to pi inclusive. Okay, so that's very important to remember the domains and ranges of these functions. Cos inverse of 2 doesn't make sense, and cos inverse gives you an answer from 0 to pi, so it's always giving you a positive number, or occasionally 0 if you put 1 in, right? Cos inverse of 1 is 0. That's a tricky one. Cos inverse of 1 is 0. Test it out on your calculator. You'll see it's true. Okay, next up, sine inverse. Sine inverse of x. Again, that is a y coordinate. We're plugging a y coordinate from the unit circle in. If we think about y values, we range from -1 at the bottom of the circle to 1 at the top of the circle. So our domain similarly is from -1 to 1 inclusive. The range for sine inverse is different from the range for cos inverse. Sine inverse's range is from -pi/2, -pi/2 is at the bottom, all the way to pi/2. So that's all these numbers, all these angles in the right half. So any of these angles can be answers to sine inverse. So it's only going to give you angles in quadrants 1 and 4. All right? And so it's really important to keep track of this range again for sine inverse, because it undoes sine, kind of. You have to keep track of the corresponding y that's in that range of angles, from -pi/2 to pi/2. Tangents domain. Tangents, these inputs are y coordinates for sine, y coordinates. These guys are slopes. So the inputs into tangent are slopes, and there's any possible slope from the unit circle. So if you think about the unit circle again, you could have a slope. Slope is 0 here, slope is increasing, and steeper, and steeper, and steeper, and decreasing, and decreasing, and decreasing, and decreasing. So you can have any possible slope for inverse tangent. So you can plug any number into inverse tangent. And then for for the range of inverse tangent, it's only going to give you angles from -pi/2 to pi/2, similar to sine. So, and we don't actually get these values, -pi/2 and pi/2, as answers. They're actually asymptotes. They approach pi over 2 as you go to the right, and they approach negative pi over 2 as you go to the left, but it never actually equals those values because you could never plug those numbers into tangent to begin with. Okay. All right, so those are the domains and ranges of these functions. This is the most important thing to remember out of this information. What are the answers these functions are going to give you? That is the cause of a lot of confusion when you compose these together with other functions. Okay, and to start off, let's do a composition. Our next question is evaluate cosine of negative sine inverse of 0.3. So first up, I want to kind of simplify this problem a little bit. I'm going to recall cosine of a negative angle is equal to cosine of that positive angle. So this identity is due to the evenness of cosine. It's even function. So if you put a negative angle in, it's the same answer as if you put the positive angle in. And so that simplifies this problem a little bit into now cosine of sine inverse of 0.3. So that negative actually doesn't do anything to my answer. So I'm going to remove it to simplify it. So now we have to figure out what this is referring to. What's this angle? What's this problem about? So I want to just show you the approach that you should always, that I would recommend taking, is to first keep your eye on the prize. What is the answer going to look like? Is it going to look like an x coordinate, a y coordinate, a slope, or is it going to look like an angle? And in this case, we are computing a cosine of something. This is cosine of something. And so that means we're going to get an x coordinate. So we're going to get some x coordinate from the unit circle. The thing we're plugging into cosine is an angle. So we're putting an angle in. This is an angle. Okay? So we're putting an angle into cosine, and then we're getting an x coordinate out. So our answer at the end of the day is an x coordinate. That's good to keep track. Keep track of that. Okay, so sine inverse of 0.3. What is this? 0.3. Well, this is an angle, remember? The answer to sine inverse is an angle. And it's the angle where sine of that angle is 0.3, 0.3. And it's the angle in either quadrant 1 or 4, because that's the range for sine inverse. So let's go ahead and sketch the picture for this. So we're either in 1 or 4. 1 or 4. And we need sine theta to be 0.3. Well, that's a positive y. So I need my y to be 0.3 and positive. So this point on the unit circle satisfies that. It is in quadrant 1, and its y is 0.3. So this would be my angle theta. That's theta right there. And the coordinates are something 0.3. Okay? We are interested in finding this something. So I'm going to just highlight the side we're interested in. We want cosine of theta because we replace this whole thing inside with theta. And sine inverse of 0.3 is that theta, that same theta right there. So cosine theta equals x. That is this side right here. It's equal to that x value. So to find this x value, or we could use t, either way. To find this x value, we remember the Pythagorean theorem. We know we've got x, 0.3, and 1 as our sides of the right triangle. And to find x, we would use the Pythagorean theorem to find this. So we've got 0.3 squared plus x squared equals 1. And this is turns into 9 out of 100 plus x squared equals 1. And so x squared is equal to 91 out of 100. So x equals root 91 out of 10. Okay, and so the answer at the end of the day is root 91 out of 10. Okay, and we know it's positive root 91 out of 10 because that angle was in quadrant 1. And the original one was actually, if we were to look at this original angle that we started off with, and we didn't apply this identity, this evenness identity, this one I was talking about earlier, that angle would be in quadrant 4 because sine inverse 0.3 is an angle in quadrant 1, and then when you change the sign to a negative, you would end up in quadrant 4, but you'd end up getting the same answer because the x is the same. If you were to sketch that angle as it's negative, you'd have the same x coordinate. Okay? So either way gets you there. Okay, next question. Evaluate sine inverse of cosine of 3 pi over 5. Well, again, my suggestion is to keep your eye on the prize. What is the result supposed to be? And then we're going to work our way to simplify this till we understand, till we have a good diagram and we can solve the problem. So the end result is an answer to sine inverse. So this is ultimately an angle. So we are ultimately going to get an angle, and the answer is going to have to be from negative pi over 2 to pi over 2. Okay? So without actually doing any work, I just look at the outermost function is a sine inverse. So that means we're getting an angle from negative pi over 2 to pi over 2 as the answer. Okay? Now let's go ahead and start tackling each piece of this. So the inside, starting with that, let's call the answer to the inside t. So cosine of 3 pi over 5 is equal to some number t. And so we have a diagram we can draw to represent this. Here's my diagram. 3 pi over 5 as an angle. If we were to cut up pi into fifths, we would want 3 of them. So if we cut it into fifths, that means we would have 1, 2, 3, 4. 1, 2, 3, 4, 5. And so this would be 3 pi over 5 right here. I know it's in quadrant 2. This is 3 pi over 5. I'm going to just erase these other ones so that we're less confused by them. That would be roughly 3 pi over 5. I know it's in quadrant 2 because it's more than pi over 2. It's more than a half of pi. Here's 3 pi over 5. Okay? So cosine of 3 pi over 5 is the x-coordinate. And we commonly just label that side of the triangle as t, as the x-coordinate here, t. So 3 pi over 5 is my angle, and cosine of 3 pi over 5 is t. So what are we trying to find? We're trying to find sine inverse of t. That's equal to the angle where sine of the angle, equals t. So we are interested in finding what theta, what angle, would we take the sine of and get that same value t that we have in this picture over here on the right. So where does this triangle belong? From the diagram, it should be clear that t is negative. So we see t is less than 0. We see that t is a negative value because it's the x and we're in quadrant 2, so that's where x's are negative. And so now when we try to draw the triangle for sine theta equal to t, well, that's going to be in quadrant 4. So our t becomes the y-coordinate because now sine of theta equals t. So this is theta. Theta is there, and this is t. That is our side t over. Okay, so sine theta is the y, and the y is t. And again, we know this is in quadrant 4. Theta is in quadrant 4, Q4, because that's where the sine is negative, and the angle is from negative pi over 2 to pi over 2. Okay, so we just have to figure out what that angle theta is. Using our, congruent triangle relationships and complementary angles. So let's do some labeling. So we can see, for example, this angle here is 2 pi over 5. So I'm going to label that. That's 2 pi over 5 because it completes the 3 pi over 5 angle to pi. So if we were to add 3 pi over 5 and 2 pi over 5, we would get pi. And it's important to note that this is the adjacent angle to t in this green triangle, and so that's congruent to this angle right there. So those are the same angles. And so this angle here is 2 pi over 5. And so then that tells us that theta plus 2 pi over 5. I'm really going to make a distinction here that it's in fact the absolute value of theta. It's not, theta is actually a negative angle because we can see that it's a negative angle since it's counting clockwise. But the absolute value of theta plus 2 pi over 5 equals pi over 2. So these are both complementary. Okay? And so if we were to subtract, we would get the absolute value of theta equals 1/2 minus 2/5 is, I'm going to just do it all the way out. We have 5 pi over 10 minus 4 pi over 10, which is equal to pi over 10. Pi over 10. And from the diagram, we see that theta is in fact negative pi over 10. So it's got the magnitude of pi over 10 as the angle, but again, it's clockwise, so negative, okay? So keep track of that. So that would be the answer for theta. It's negative pi over 10, okay? And we can always compute this and check it with the calculator, make sure that that's correct. All right, question 4. This one's about matching graphs of sine inverse, cosine inverse, and tan inverse. So I'll just graph each of these. For sine inverse of x, that function looks a lot like sine, but flipped across the y-axis. So remember, sine inverse of 0 is 0, and sine inverse of 1 is half of pi. So there's pi over 2. And then sine inverse, that's 1, here's negative 1, is negative pi over 2, negative pi over 2. So those are the key points to remember. And so what would it look like? It would look like, so sine kind of curves out that way, so this one curves up this way, this one curves down that way. So there's our graph for sine inverse x. Let's do the graph for cosine inverse. This one's a weirder one. So if we were to evaluate cosine inverse of 1, we get 0. And then we have pi over 2, 1, and negative 1, and then pi. So if we plug negative 1 in, we get pi. If we plug 1 in, we get 0. If we plug 0 in, we get pi over 2. So this is the graph of cosine inverse. It looks kind of weird. Remember, for these 3 key points, this is negative 1 pi. This one is 0 pi over 2. And this one is 1, 0. Just remember the key points on the graph of cosine from 0 to pi. So these are the flips of all of those. And then lastly, inverse tangent, tan inverse of x. This is a weird one with 2 horizontal asymptotes at pi over 2 and negative pi over 2. And so we've got these horizontal asymptotes that kind of bound this function above and below. At 0, it's 0. And then as we go to the right, we're going to head towards this asymptote. And as we go to the left, we're going to head towards this asymptote. It kind of jogs in the middle. So that's our nice, cool inverse tangent graph. Okay? So those are the three inverse function graphs that you want to keep track of. All right. So next we're going to do, this question is a three-parter. We have sine inverse of t equals negative 0.5. We want to evaluate cosine inverse of t, sine inverse of negative t, and cosine inverse of negative t. So we'll start off by sketching a diagram for this. So sine inverse t equals negative 0.5. That's an angle. Whoops, negative 0.5. So that's a kind of funky angle. We need to keep track of where this angle is. And it's the same as saying that sine of negative 0.5 equals t. So we're going to diagram this. So if we were to diagram this, we have a negative 0.5 radian angle. So that's about a third of the way down because this is negative 1.57. So negative 0.5 is somewhere around here. And so the sine of that angle is t. So here's the sine. That's negative 0.5. Okay? The angle is negative 0.5 and the sine of that is t. If we want to evaluate cosine inverse of t, cosine inverse of t is another angle. This equals theta, where cosine of theta equals the same t we drew over here. So that t. Remember, t is negative from our diagram, so cosine of theta is negative, and that's going to be in quadrant 2. So this is now t over here. There's t, and this is theta. That's what we are interested in. So our answer should be more than pi over 2. Okay? We're going to go ahead and label angles we know. So this angle is congruent to this angle right here. Those are the same, and this one is 0.5. 0.5. And so if we use that fact that this is pi over 2 and this is in the same as 0.5, then I just need to add 0.5 to pi over 2 to find theta. So theta is pi over 2 plus 0.5. So that would be what theta is. Okay, so that's the diagram for A. I'm going to go ahead and erase all the green stuff. So there's the green stuff. Okay. Nice. Oh, I got rid of that one. Oh well, let's fix that. Okay. So next up, we're going to find sine inverse of negative t. Again, this is equal to an angle where the sine of that angle is negative t. And so it's going to be another angle than the one we see here that's negative 0.5. So now we want the sine to be negative t. So again, t is negative already. So if we flip the sine of t to be negative t, then we have a positive t. And so this would be the angle. This is theta, where the y is negative t. And clearly we can see from the diagram these triangles are the same. This angle is congruent to that angle, so that means that theta is 0.5. Easy peasy. Okay, let's move on one more time to the last question. Cosine inverse of negative t is an angle, and we need cosine of that angle to be negative t. So we could use our result from A, but if we didn't have to do A to get this one, let's just diagram it. I'm going to diagram it in blue. So again, negative t is positive. And so where is the cosine positive? Well, that's going to be in quadrant 1. So I need my cosine to have I need my angle to have an x that's negative t. All right, so this is theta. That's the theta we want. And again, we can see this is 0.5. These are congruent up here. So this angle is 0.5. And so theta plus 0.5 equals pi over 2. Those angles add up to pi over 2. And so theta equals pi over 2 minus 0.5. Okay, those are the three results. If we had done A first before we did C, like we did, we could have taken our answer from A and subtracted it from pi, and that would have given us the answer to C. Okay, so we could have also used that fact to get the answer for C. Okay, last question. Write an expression equivalent to cosine sine inverse of t that only contains t. So we need to write a function this is equivalent to that just contains t's in it. Okay, so it doesn't have cosines and sines. So this is it's phrased differently on the problem, the practice quiz. But I'm going to go ahead and do this problem in this phrasing. So first we're going to start off by saying, okay, this is an x-coordinate. My answer is an x-coordinate, just to keep track. So answer. That's an x-coordinate because it's the result of a cosine. Inside we've got sine inverse of t, so that means let's go ahead and label this as an angle. So sine inverse t is an angle, whoops, where sine of that angle is t. So we're going to draw a diagram to label this. So we have theta, and sine of theta is t. So that means that I'm going to label this side t and the hypotenuse 1. That way the sine of theta is t over 1, which is t. To compute cosine of theta, cosine of sine inverse t is just cosine of theta. Well, I need to find this side here. It's equal to x over 1. So to find x in terms of t, I'm going to use the Pythagorean theorem. So this gives me x squared plus t squared equals 1. And so x squared equals 1 minus t squared. So x equals the square root of 1 minus t squared. And so this is going to equal root 1 minus t squared. And it's important to think, okay, does this make sense for values of t that I could plug in? And if we think about, and this is the formula, and it works actually for any t you could plug into sine inverse. Remember, sine inverse of t, this guy, I'm going to use another color to talk about this. Sine inverse of t is an angle, and the angle is in the set from negative pi over 2 to pi over 2. So the only things we're plugging in to cosine in this example are angles in the right half. So angles over here. All right? In all of these instances, cosine is positive. Okay? So no matter what t you plug in, sine inverse is going to give you an angle that's somewhere in the right half plane, where cosine is positive. Hence, the positive square root is the one we want. And that works for any t you could plug in. So if you put a negative in, you'll get a negative angle, but the cosine of that is still positive. If you put a positive t in, you'll get a positive angle inside, and the cosine of that is positive. And so it doesn't matter if t is negative or positive, we'd still get that same positive result, square root of 1 minus t squared. I would encourage you to check this with a calculator to just see that that in fact holds for any value of t you could plug into sine inverse of t. Okay? All right. Those are all the questions. I'm going to put in the video description links to, I should have said this earlier. It's too late now. I'm going to put in the video description links to each of the sections, so feel free to just bounce around and say, oh, I want to just watch question 1 or question 3 or whatever. So, all right, good luck studying, and I'll see you in class tomorrow.